In most scenarios, a switch breaker is the appropriate choice for controlling power to an elevator. A switch breaker integrates a built-in switch, enabling manual on and off operation. This functionality is crucial in situations demanding the ability to manually disconnect power to a circuit. The National Electrical Code, specifically Section 430.28b, addresses the use of switch breakers. This section mandates that when switches are employed to disconnect elevator branch circuit conductors, they must possess a horsepower rating equal to or exceeding the horsepower rating of the motor powered by these conductors. For elevators, the switch breaker serves to disconnect power to the elevator motor. It is essential that the horsepower rating of the switch breaker matches or surpasses that of the elevator motor. The use of a shunt-trip breaker for elevator power control is generally discouraged. A shunt-trip breaker operates by tripping in response to a signal from an external device, for example, a fire alarm system. Shunt-trip breakers are commonly used when remote power disconnection is necessary. While suitable for remote disconnection, a switch breaker is better suited for local, manual control of an elevator's power supply. Firstly, it is crucial to understand the fundamental differences between a switch breaker and a shunt-trip breaker. A switch breaker acts as a standard circuit breaker, protecting against overcurrents and short circuits, while also incorporating a manual switch for on and off control. This allows personnel to easily de-energize the elevator for maintenance, repairs, or in emergency situations. Secondly, a shunt-trip breaker, on the other hand, is designed for remote tripping. It requires an external signal to activate the tripping mechanism. This signal typically comes from a fire alarm system or other safety device. While it can disconnect power to the elevator, it lacks the convenient manual control offered by a switch breaker. Thirdly, the NEC Section 430.28b specifically addresses the use of switches for disconnecting elevator branch circuit conductors. This section emphasizes the importance of selecting a switch with an adequate horsepower rating to handle the motor load. Using a shunt-trip breaker in place of a switch breaker may not comply with this requirement, as shunt-trip breakers are not typically rated in horsepower. Fourthly, the operational differences also play a significant role. A switch breaker allows for quick and easy isolation of the elevator's power supply. This is especially important during maintenance or troubleshooting, where personnel need to ensure the elevator is completely de-energized before commencing work. Fifthly, consider the safety implications. A switch breaker provides a clear and visible means of disconnecting power, reducing the risk of accidental energization during maintenance. With a shunt-trip breaker, the disconnection is typically triggered remotely, which may not be immediately apparent to personnel working on the elevator. Sixthly, the reliability of the disconnection mechanism is another factor. A switch breaker offers a direct mechanical disconnection, which is generally more reliable than the electrical triggering mechanism of a shunt-trip breaker. Seventhly, the cost-effectiveness of each option should also be taken into account. While shunt-trip breakers may be suitable in some specific scenarios, switch breakers are often more cost-effective for general elevator power control. Eighthly, the ease of installation and maintenance should be considered. Switch breakers are typically easier to install and maintain than shunt-trip breakers, which require additional wiring and connections for the remote tripping signal. Ninthly, the specific requirements of the elevator system should be evaluated. Factors such as the motor horsepower rating, the presence of other safety systems, and the frequency of maintenance should be taken into account when selecting the appropriate breaker. Tenthly, always consult with a qualified electrical engineer or inspector to ensure compliance with all applicable codes and standards. They can provide guidance on the best solution for the specific elevator installation. The NEC provides comprehensive guidelines for electrical installations, and adherence to these guidelines is crucial for ensuring safety and preventing electrical hazards. Furthermore, it is important to note that the NEC is updated regularly, so it is essential to stay informed of the latest revisions. The NEC is not intended to be a design manual, but rather a set of minimum safety requirements. Therefore, it is important to go beyond the code requirements and consider other factors that may affect the safety and reliability of the electrical system. For example, The NEC may not specifically address the use of surge protection devices, but these devices can be valuable in protecting sensitive electronic equipment from damage caused by voltage surges. Similarly, the NEC may not require the use of arc fault circuit interrupters, arc fault circuit interrupter breakers in all circuits, but these breakers can significantly reduce the risk of electrical fires. The selection of electrical equipment should be based on a thorough understanding of the application and the operating environment. Factors such as temperature, humidity, and the presence of corrosive substances can all affect the performance and lifespan of electrical equipment. It is also important to consider the potential for future expansion or changes to the electrical system. Choosing equipment that is easily expandable or adaptable can save time and money in the long run. Regular maintenance and inspection of electrical equipment are essential for ensuring its continued safe and reliable operation. This includes periodic testing of circuit breakers, visual inspections of wiring and connections, and cleaning of electrical enclosures. Any signs of damage or deterioration should be addressed promptly. The National Electrical Code is a comprehensive set of standards for electrical installations. It covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. The NEC is updated every 3 years, and it is important to stay informed of the latest revisions. The NEC is not a law, but it is widely adopted by state and local jurisdictions. Compliance with the NEC is often required for insurance purposes. The NEC is intended to provide minimum safety requirements for electrical installations. It is not a design manual, and it does not cover all aspects of electrical system design. The NEC is based on sound engineering principles and industry best practices. It is developed by a committee of experts from various fields, including electrical engineering, construction, and safety. The NEC is constantly evolving to reflect new technologies and changing safety concerns. The NEC is an essential resource for anyone involved in the design, installation, or maintenance of electrical systems. It provides the information needed to ensure that electrical installations are safe and compliant with applicable codes and standards. To reiterate, the NEC Section 430.28. V specifies that where switches are used to disconnect elevator branch circuit conductors, they shall be of the type having a horsepower rating that is not less than the horsepower rating of the motor supplied by the conductors. This means that if you're using a switch to cut power to an elevator's motor, the switch must be rated to handle at least as much horsepower as the motor produces. This is to ensure the switch can safely handle the electrical load without failing or causing a hazard. The horsepower rating of a motor indicates its mechanical power output, but it also relates to the electrical current it draws. A switch with a lower horsepower rating than the motor could overheat, arc, or even melt under the load, creating a fire risk. Therefore, it is critical to adhere to this requirement. In the context of elevators, using a shunt-trip breaker as the primary means of turning the elevator on and off is generally not the recommended practice. Shunt-trip breakers are designed for emergency or remote shut-off situations, often triggered by a fire alarm or other safety system. They are not intended for regular on-off switching. A shunt-trip breaker is a type of circuit breaker that can be tripped remotely by applying a voltage to a shunt-trip coil. When the coil is energized, it causes the breaker to trip, interrupting the circuit. This is useful for quickly de-energizing a circuit in response to an emergency or fault condition. However, shunt-trip breakers are not designed for frequent switching. The repeated tripping and resetting can wear out the mechanism and reduce its reliability. Furthermore, a shunt-trip breaker does not provide a clear indication of whether the circuit is intentionally turned off or tripped due to a fault. This can be confusing for maintenance personnel or emergency responders. A switch breaker, on the other hand, provides a clear and reliable means of turning the elevator on and off. It is designed for frequent switching and provides a visual indication of the circuit's status. A switch breaker is essentially a standard circuit breaker with an added switching mechanism. It protects against overloads and short circuits, just like a regular breaker, but it also allows for manual on-off control. The switch is typically a toggle or rotary type that is clearly labeled and easy to operate. When the switch is in the off position, the circuit is de-energized, and when it is in the on position, the circuit is energized. This provides a simple and straightforward way to control the elevator's power supply. In summary, for controlling the power to an elevator, a switch breaker is generally the preferred choice over a shunt-trip breaker due to its suitability for frequent switching, clear indication of circuit status, and compliance with NEC requirements. Using a shunt-trip breaker for regular on-off switching can lead to premature wear and tear and potential safety hazards. Always consult with a qualified electrical professional to ensure compliance with all applicable codes and standards.